Welcome to the ultimate guide for building your own Security Operations Center home lab. Practical, hands-on experience is the foundation of cybersecurity. A home lab allows you to simulate real-world attacks, practice threat detection, and master incident response in a safe, controlled environment. Today, we will build an enterprise-grade setup using Proxmox, pfSense for networking, and Security Onion as our centralized monitoring stack. Before we begin the installation, let's review the hardware requirements. A SOC lab is resource intensive due to heavy log processing. At a minimum, you'll need 16 gigabytes of RAM and at least 4 CPU cores. However, for a smooth experience, we recommend more. For a production-like feel, 64 gigabytes of RAM and 12 CPU cores will ensure Security Onion and your target VMs run without performance bottlenecks. We'll start with Proxmox as our hypervisor. It provides the flexibility to manage virtualized networking and diverse operating systems. The foundation of any SOC lab is network segmentation. We need to ensure that traffic is isolated and observable by our monitoring tools. In Proxmox, navigate to System, then Network. Create a new Linux bridge named VMBar1. This will handle all internal lab traffic. To capture traffic effectively, we will use an open vSwitch bridge. This acts as a virtual spam port for our monitoring stack. Run the command apt install open vSwitch-switch in your Proxmox shell to enable advanced port mirroring capabilities. Create VMBar2 as your sniffing bridge. This ensures Security Onion sees all packets, even if they aren't destined for its management IP. Next, we deploy pfSense. It acts as our central router and firewall, separating the internet from our internal lab zones. Assign 2 gigabytes of RAM and 2 CPU cores to the pfSense virtual machine. Ensure you attach at least 2 network interfaces. Connect the first interface to VMBR0 for WAN access and the second to VMBR1 for your internal lab network. Follow the standard FreeBSD installation prompts. Once installed, assign your interfaces, usually VTnet 0 for WAN and VTnet 1 for LAN. Access the web GUI to begin segmentation. We will create specific VLANs for our attacker and victim machines. Configure VLAN 10 for your offensive tools and VLAN 20 for your target machines. This separation is crucial for realistic traffic analysis. Set up DHCP pools for each segment. This ensures every VM in your lab receives a consistent IP address within its designated zone. Now we define our firewall rules. The attacker needs to reach the victims, but the victims must be blocked from your home network. This policy prevents malware or scanning activity from escaping the lab environment and affecting your primary devices. With our network ready, it's time for Security Onion, our all-in-one platform for IDS, network security monitoring, and log management. Security Onion is the most resource-intensive part of the lab. Assign it at least 16 gigabytes of RAM to prevent log indexing issues. Assign 2 network interfaces to the Security Onion VM, one for management access and the second for capturing mirror traffic. Crucially, set the sniffing interface to promiscuous mode in Proxmox. This allows the VM to see all traffic crossing the virtual bridge. Run the Security Onion setup wizard and select standalone mode. This integrates the entire stack into a single virtual machine for our lab. The installation automatically configures the AOK stack, providing powerful log visualization and historical analysis capabilities. Now we need our protagonists. We'll start by deploying Kali Linux in our attacker VLAN. Download the Kali ISO and attach it to VLAN 10. This ensures it can communicate with our targets through the controlled pfSense gateway. Install the QNU guest agent on your Kali VM. This allows Proxmox to manage the VM state and report accurate IP data. Next, we set up our target machines. For beginners, Metasploitable 2 offers a target-rich environment for practicing basic exploits. If you're using a Windows target, install Sysmon. This provides the granular endpoint telemetry necessary for detecting modern threats. Use WinLogB to ship these endpoint logs to Security Onion. This bridges the gap between network visibility and endpoint reality. With all components deployed, it's time for the most exciting phase, verifying that our pipeline is working. From your Kali machine, we will generate some low-level noise to see if our monitoring stack picks it up. Run a simple Nmap service discovery scan against your victim's IP. This generates predictable network signatures for our IDS to detect. Log into the Security Onion console. Under the Alerts tab, you should see triggers from Suricata identifying the Nmap activity. Navigate to the hunting dashboard. Here you can drill down into the raw Zeek logs to analyze the specific DNS queries and HTTP headers. Verify your endpoint logs as well. you should see a network connection event originating from your Kelly IP and targeting the victim. Once the basic pipeline is confirmed, you can start adding more complexity, such as an Active Directory domain or custom EDR agents. This lab is now your playground for threat hunting. Use it to reverse engineer malware behavior and test new detection rules. The goal is a continuous cycle of learning. Each attack you simulate teaches you how to better protect your enterprise environment. If you don't see alerts, check your promiscuous mode settings and ensure pfSense firewall rules aren't blocking internal traffic. Monitor your Proxmox resource usage. If Security Onion becomes sluggish, consider increasing its memory allocation or optimizing the storage. As your skills grow, you can scale this lab across multiple physical nodes using Proxmox clustering for high availability. Consider using automation tools like Ansible to deploy and configure your lab components consistently and efficiently. Leverage the security community. Many experts share pre-built lab templates and detection playbooks on platforms like GitHub. Keep your lab maintained. Regularly update your monitoring signatures and rotate your target OS versions to keep the experience fresh. Document your findings. Building a lab journal is a great way to track your progress and build a portfolio for your career. The skills you develop here, from networking to log analysis, are directly applicable to a professional career as an SOC analyst. Mastering these industry standard tools gives you a significant advantage in technical interviews and on-the-job performance. By simulating real-world scenarios, you'll be ready to face the complex challenges of a modern security operations center. Building a SOC lab is a journey of exploration. Don't be afraid to break things. That's often where the most valuable learning happens. Start today. Download Proxmox, configure your network bridges, and begin deploying your first monitoring stack. Later, you can explore cloud integrations and hybrid lab environments to expand your defensive capabilities even further. Developing a strong defensive mindset is a lifelong pursuit. Your home lab is the first step on that rewarding path. Share your progress with others. The cybersecurity community thrives on shared knowledge and collective defense strategies. The world needs skilled security analysts. Take control of your career and start building your SOC home lab right now. From Proxmox to Security Onion, you now have the blueprint. It's time to turn this plan into a powerful learning environment. Thank you for following this guide. Good luck with your build and stay curious in your journey through cybersecurity.